Welcome back again, guys. This is NYD Designs again. This is the last section of our design, where we want to achieve the interesting architectural element structure made by a Japanese architect called KAGOME pattern and columns. So during the first sections, we have created those curves running in 3 different directions. In the second section, we have created the space where we can erect our column, and during the last section, which was the third, we achieved this interesting column from this center running outwardly with a shape changing from the smallest size to the largest side to the top, and also being able to take and connect all the curves. So during the last section we are going to pass through, we'll give the thickness to those curves, and after arrange them, make a series of columns, as many as we want, in order to achieve a real structure which can be constructible. So be with me until the end so that you could get a very useful architectural knowledge you could apply by yourself. So what we will do here, we have projected the curves to the breadth up. So next we will give them the thickness. So in order to give them the thickness, what we will do, we will offset, use a command called offset curve. We will offset them in both directions. Offset curve, this one, so offset them. So what we do here is a distance to offset. We offset them in 2 directions, so we use command called mesh. Mesh 0.5. Okay, 0.5 is enough. And the negative in the negative of it, in order to get it in another direction, which is this. So we do that, and this will be here. So now we have offset it. This one will be the projected stuff. Now we have projected our offsetted curves upward, you see. So we can increase the size of this offset distance by increasing this number. Maybe you can increase it, see, that's the way you want. So 0.5, that is enough. So after offsetting them, what we will do, we find a way to loft between those curves. Because there are 2, we will have to use a command called trim path. Trim with, yes, we use trim tree with 2 curves, this one, so it will help us to loft between those curves, and we loft. Okay, now we have lofted between those curves. You no longer need make you off. So now we have a loft. We're starting to have the surface of our structures. So what we'll do, we'll give the thickness to those structures. So we use a command called offset surfaces. Offset surface, that's one. So you see, now we have the thickness, so we give it maybe a distance of 0.5 can be enough, but because we need it in 2 direction, so we have to use negative, and we apply it in other direction like this. So now finally we have structure. We have structure of elements learning from down with thickness and going upward and distributed and connected to others, so that they become strong and aesthetically good. So what we do next, we will arrange, we will make a series of those columns. Maybe we can create 4 columns connected together. We can increase them, become 10 or 20, but we make them 4, as many you want. We use a command called array. Rectangular array. So we will arrange in X direction and Y direction. And we arrange 3 components in X and 3 components in Y. Okay, but let me make it 1 because it is very heavy, and apply it. So what we will do, you see, we are remaining with this sheet. It's called rectangular array cell. This will give us the exact number we can arrange. So in order to get the value of that scene, we come back at the start and there apply 2 expressions. There are formulas which will help us to immediately get the values for that scene, so that we can make series of those columns. So here we use 2 expressions. There are 2 formulas. Use a command called expression. This one, copy and paste. So this x, this variable x will be, we name it r. This r, yes, for all will be r, and this will be x. Yes, and this r will be this the size of the hexagonal cell we started with, so it will be this one. And here we made a mistake here. We copy this one and separate them. Separate them with this. Yes, like this. Okay. And in X we connect this one, and we'll give the expression, the formula we use will be This one, it will be x times r, I think, over x times r, or plus x over 2 times r, plus x over 2 times r. Okay, that's the formula for this first expression. So for the second, here r will be this one, and this y will be connected here. Here we use a formula. We use this formula. It is y times r times 2 times cosine pi over 6. Y times r times 2 times cosine pi over 6. Yes, that's it. So those are the two expressions. So here we extract a rectangle from there. This rectangle, it is the size of a rectangle we array within. So use command rectangle. So we connect this one to x, this one to y. So we extract their curve. Yes, no longer need here, I think. Also, we use this curve to arrange our structures. So we move this curve way up to here. This is C. This curve will be our C. So we just wait. It is loading. It is thinking. It is thinking. Finally, it's end. Okay. Let me increase this number maybe to 2 in order to get 4 columns. It is thinking. Okay. Finally, we get 4 columns. You see? Those are our 4 columns. We can increase them or decrease them as the way you want by increasing this number. If you make 3, it will be 6. If you make them this 4, it will be 8 columns. So this is our structure. We have achieved it. Thank you. Thanks to God, we have achieved our structure. So there we have these stuffs. So this is our structure. This one we bake it in the sea. Can make it this one off. This is our structure we wanted. So we change it to maybe rendered. If it will work. Yes, it's rendered. You see, it's interesting. can change the color. Yes, that's what we wanted. So okay, thank you for being with me in this very long journal, which was comprising 4 sections. So this is KAGOME pattern. I hope you have gained the very useful architecture knowledge you can apply by yourself. So thank you for being with me. May God bless you. Bye.